All right, we're back again. We're still talking about the red flag property inspection guide. So I want to welcome you to part 3 of our 6-part series. We invite you to join for each of our webinars. If you haven't seen the previous ones, they'll be on the InterNACHI website. And if you have questions, you can email me, paul@internachi.org. And again, this is Paul Roebuck presenting to you about red flags. So hope you enjoy our video and webinar. If you have questions or comments, please email me and I'll gladly answer your questions and get back to you as soon as I can. Okay, talk about proper drainage, building ventilations, hillside instability in fields. Proper drainage of a roof and yard areas is very important because water collects near the house. And underneath it, if it's a pier and beam, it can cause some existing soil problems that are aggravated and make them even swell and move and cause all types of foundation issues. Expansive soils where when exposed to large volumes of water, it's going to swell and their maximum swelling, and then they shrink dramatically when they dry again. So you'll get a lot of ups and downs and enlarge and decrease, and it causes foundations to move because foundations are solid objects, but the soils of the ground they set on could definitely cause some movements to occur, and which could cause some foundation failures. Many foundations can't tolerate these maximum shrinking and swelling cycles that happen. Rain seasons, dry seasons, things happen, and the foundation just can't tolerate it. When a homeowner allows these conditions to exist, cracking and settlement, it begins to happen, and just the results are there. Proper drainage away from the house is vital. Water is not properly drained away from the house. This will cause heaving around the house slab itself. So even when we have let's say a really wet season occurring, if the drainage drains away from the house, away from the foundation, that's the best thing you can do because it keeps the water from collecting or ponding right around the house. Large fill soils will sag, settle, and causing damage if they're not kept well drained. So again, the drainage around the house is something of vital importance. The building codes require the slope away from the house, at least the first 10 feet, to slope a minimum of 6 inches. That's a good slope if you think 10 feet, but as you walk around the house, you would noticeably see that it slopes. Now, some of the houses in subdivisions where they build them right next door to each other, you don't have 6 feet between the two properties. They have to drain them in between towards the middle of the division of the yard. Then they put in some type of a drain system, underground French drains, or just a drain to drain it out to the street or wherever they're going to run the water off to. But if water pools right next to a foundation, it can easily seep into the house, under the house. It can cause voids under the foundation, basements flooding, wood rot, damage to heat ducts and swelling wood floors. All kind of bad things happen if the water is not drained away from that property correctly. Anyway, French types of drains they install. Some of them are French, some of them are underground type drains. These are usually not something we inspect during a home inspection. If it's not visible, then it's not something we can inspect. In other words, you don't have X-ray vision, and we can't check underground drainage systems. A French drain is defined as a drain consisting of an underground passage made by filling a trench with loose stone covering the earth, called also rumble drain. But other underground type drains may simply drain into another section of the yard or into the street. These are usually not inspected during a home inspection either. So if you can't see all of it, you can inspect it. So let your client know that's, if you can't see it, you can inspect it, and it would be beyond the scope of the inspection itself. Proper grade and drainage away from the house is critical, though. Water, if it's not properly drained away from the house, can cause foundation movements to develop. During certain dry or wet seasons, foundation movements can occur very rapidly. Roof gutters should not drain near the foundation or hard surface joints. Heaving can occur because of excessive water. Lots of soil, depending on the particular type. If it gets wet, it swells. It dries, it shrinks. So you don't want an amount of the roof wherever it goes in that gutter. Sometimes those gutters collect heavy amounts of rain coming through a little 5 or 6 inch gutter, and that can cause excessive water swell in one spot. And I've actually seen foundation issues develop because of improper installation of gutters. Why does that happen? Well, that's a good answer. Good question, I should say. They happen because the gutter guys don't know anything about structural issues of a house. That's not their job. They get paid to put gutters up. So they put the gutters up, finish their job, get paid, they're down the road. If you have foundation issues, don't call them. They just installed the gutters. So a lot of times it's the nature of the beast, things that happen in construction. And that's pretty much so with every contractor. Electrician don't care about the HVAC guy. HVAC guy and the electrician, neither one care about the plumber. And none of those guys care about the framer. If something's in their way to finish their job, knock it out, cut it out, whatever, and get their job done so they get paid. So that's where you and my experience comes in vital to someone building a home. If you're not doing pre-drywall type inspection or phase inspection on new construction, get qualified. And that's definitely a way you can add a lot more money to your company's bottom line. All right, building ventilation. The underfloor space between the bottom of the floor joist and the earth under any building, except maybe some space occupied by a basement or cellar, shall be provided with ventilation openings through foundation walls or exterior walls. The minimum net area of ventilation openings shall not be less than 1 square foot for each 150 square foot of underfloor space area. That's important because that keeps the air movement and keeps moisture from developing, which can cause, as we know, rot, insect infestations, mold. So there's all kind of stuff. We want the air to flow up underneath the house. The ventilation openings must be within 3 feet of each corner of the building. Enclosed attics and enclosed rafter spaces form where ceilings are applied directly to each separate space by ventilating openings protected against the entrance of rain or snow. So ventilation of a building is vital to the building's functionality and to keep from having any red flags begin to develop because of the lack of ventilation. Ventilation openings shall be provided with a corrosion-resistant wire mesh that has 1/8 inch minimum and 1/4 inch maximum opening. We want to keep critters out of it, keep bugs out of it, but it still has to be able to vent. The ventilation portals must be screened to prevent the entrance of rodents and insects. The integrity of the ventilation portals shall be inspected and should be reported if they're damaged. A lot of time homeowners don't want to see openings underneath their house, so they'll seal it off totally. If you find a house that's on pier and beam and there's no ventilation around the house, you can almost guarantee yourself there's going to be some type of structural issues under it because of decay, wood rot, soil movement, foundation issues. These are red flags. Those are the lack of these is something you definitely will look at and be sure to write them up in your report. Ventilation openings should be protected from inside the attic to prevent insulation from blocking the soffit's vent openings. IRC codes require the installation of what we call baffles. These are little pieces, looks like same material like most foam or styrofoam type of egg cartons are made out of. They kind of look like that, but they're the width of the space between the rafters, and they go in between the rafters to allow a minimum of a 1 inch vent above the baffle and insulation materials. So these are slid into the attic space before the insulation is installed, and this to allow airflow from the soffit vents up through the attic and vice versa. So ventilation, if you don't see that, it's an issue. If you have a continuous soffit vent on the outside of the house, these have to be installed in each rafter opening. So it's not every other rafter. You should see it in every one. And you can see it during the finished home inspection. You can look across with your light, shine at the edge of the roof, and you should see these cartons. I've even seen them use cardboard boxes for it. They use a lot of things. So as long as you got some type of ventilation going on, it's what you want to look for. Okay, foundation maintenance. Let's talk about that for a little bit. As red flags, we look for on inspection, having a good drainage system pull water away from the house and prevent it from pooling around the foundation. This includes sloping your yard away from the house, having proper gutter systems with appropriately placed downspouts to draw rainwater away from the foundation. Keeping gutters cleared is a simple thing that can prevent a lot of issues to your foundation, landscape, even your roof, and also keep water from backing up and causing rotted decking, rotted cornice sections, water getting into the house even. But make sure you never plant trees closer than 20, 25 feet from your foundation. Now, this is an issue because what we have seen is landscapers will come in and they'll put a tree that's going to grow in 15, 20 years to a massive tree within 5 feet of the foundation. Well, as that tree grows, the tree roots will grow outward from the tree and can grow longer than 30 feet away easily, which means infiltrating your foundation, which you don't want. Also, the trees get so big that they begin to touch the roof. As wind blows, shingles get damaged. Tree, I mean, it's you have to keep the distance away from the house, is what I'm trying to tell you. So when you see trees closer than that to a house, it's an issue. If you live in an area where you have a lot of pine trees, pine type trees, those trees are prone for lightning strikes. If a tree is within that 10 feet, 15 feet of a house, lightning strike hits it. That's close enough that lightning spark from that tree could spark onto the house and cause a house fire. So there's a lot of different things. Again, if storms come through and pushes a tree over, it could cause a tree to land on top of the house and cause damage. So make sure your landscape around the house has proper seals, doesn't hold water after it rains. You want to be able to keep your plants water but not soak the edge of the foundation, making the soil unsettled. My personal preference is if you around your foundation area, I like to see about a 15 to 18 inch gap between the edge of the foundation and any type of flower bed or shrubbery section that you have. I like to see it dug down a little bit where you put some bull rock in it and slope those bull rock sections of the grade away from the house where the drainage go away and still leave your slab exposure. You want to see at least 4 to 6 inches of slab exposed after the bull rock's been installed. That prevents you from having a lot of high water content getting into the house. You can let you see if there's any type of termite activities going into your house. So there's a lot of benefits to it. So it helps keep the drainage away from the house, protects your foundation too. So just personal thought on it. I like to see that. I see very few builders do it, but I'm beginning to see more do it as time goes by because they're realizing it makes just for a better home. Attic access. The International Residential Code, the IRC code, requires the installation of attic access doors and pull-down stairs to be properly insulated and weather stripped. Today, the energy codes, the International Energy Conservation Codes, require these access openings to have the same amount of R value as the attic insulation does. So if you have an R30 or R20 requirement in your area, that insulation has to be as thick on top of that little access opening and pull down stairs to make it meet code. Attics containing appliances access shall be provided with an attic with an opening and a clear unobstructed passageway large enough to allow removal of the largest appliance, but not less than 30 inches high by 22 inches wide, and not more than 20 feet in length measured from the center line of the passageway from the opening to the appliance. What does that mean? That means if you have an air handler in the attic space, the opening for you to gain access to it has to be large enough for that piece of equipment to be able to be removed and replaced. So if you got an air handler sitting in the attic, and say it's let's just say 30 by 36 inch, 6 feet long piece of equipment, that opening has to be at least big enough for that 30 by 36 piece of equipment to come out and put a new one in. So if you can only get your head in the attic to look around, you see a piece of equipment like that in the attic, that's not a proper attic access. That's something that would be written up as a deficiency, because that's a red flag. You'd rather tell the person as they're buying the property, hey, you're going to have a problem if you ever have to have this unit replaced. It's better to tell them now before they buy it than they realize it after they bought it and you didn't say a word about it. So, but as far as it has to be a 30-inch high and 22-inch wide space to get into it. But the walkway, what we call a catwalk in the attic, can't be more than 20 feet from the attic access opening to the piece of equipment. In other words, if you climb into an attic and you have to go 30 feet, 40 feet to get to the air handler or to the water heaters inside of an attic space, which in Texas we have that. In other parts of the country, not so much so. But if you have to cross over that much footage to get to it, it's too far, and there should be another attic access installed. But the attic also requires there be a solid, unobstructed walkway, and that's what we call the catwalk. Unobstructed means you don't have to cross over any electrical wires. They can't be stapled to that walkway we walk on, because walking on cables can cause electrical issues to short out. Can't have gas piping or water piping running across it where you have to step over it. A solid, unobstructed walkway means that you can take a two-wheel dolly, roll it in, hook to a piece of equipment, and roll it back out without having to cause damage to pipes, wiring, or anything else. Plus, it's safe. It keeps you walking, standing up or crawling, rather than falling over and hurting yourself or someone else in the attic space. So just something else to look at, to consider during your inspection. Those will be red flags that you definitely want to write up if they don't have those items installed. This just shows you a little bit of attic access, some of the spaces that you can see, access openings, where the equipment is. You can probably zoom in on some of these. I can to show you some of these like this. It gives you the attic access. And a lot of times, if you're doing pre-drywall inspection, you'll see these. You can easily catch it. Other times, it'd be after you're already in the place. And I can tell you, I've done new construction, even commercial buildings, where catwalks, you get in there, you don't have a good catwalk to walk around and see things. But once you do get there, you have to walk 25, 30 feet to get to air handlers in the attic space. And they've got the unit installed what I consider to be backwards. In other words, you get in like this picture here in the middle here. Let's say this is your air handler on this particular example, and the connections for the gas line or electrical on this side of the unit. Well, how in the world do you get to this little space here? You can't crawl over, you can't go around. There's not enough space. Somebody put this in backwards. So I definitely would write that up as that unit's installed, where it makes the area that's supposed to be readily accessible not readily accessible, and it's going to cause an issue down the road. So why they do that, your guess is as good as mine. I call it a bad day. I call it stupidity. I call it just inadequate knowledge of how things should be installed. Somebody just wanting to get a system in no matter what. So I've actually had it done on what they call it, a memory care facility. And there were like 6 units in the attic of this place. It was a single story and no basement. And all the equipment was installed in the attic like that. And 3 of the 6 units was installed backwards. So they weren't happy with me, but hey, it still needed to be corrected because it was installed wrong to start with. So anyway, you never know. I tell people inspecting houses is like a box of chocolate. You never know what you're going to get. But that's what makes our job fun, right? Okay, let's see. What am I here? My screen's not letting me change. There you go. Okay, hillside instability landsliding. A hillside is stable if it's likely to remain in its present form at rest without sliding or eroding. And it's going to be a judgment call on your part, because If you see a hillside, a property built on a hillside, it's going to depend on the drainage around it. It's going to depend on what type of material it is, if it's rocks, if it's stone, if it's clay, if it's sand. If it's likely to move, that could be an issue. But if it's at rest without sliding or eroding, it's probably a good build. But it's difficult for even experts to predict the future stability of hillsides. They can definitely move. I've seen them where they have a small backyard, say 25 feet from the house, a wood fence around it. On the other side of the wood fence is a canal for drainage. If that slope is so great, a lot of time that backyards just start falling off as erosions begin to occur. So look for signs that make past instability, erosion, soils that crumble slowly or falls away. Those could be signs that, hey, things are fixing to happen on this foundation, and we need to make a red flag note of it in our report just to be aware of. Now, retaining walls. What is retaining walls? Well, retaining walls use to hold soil that would otherwise slide down. They're built wood. I've seen them built out of railroad ties. They're built out of rocks. Some people have concrete poured retaining walls. There'll be a lot of different materials. So it varies from where you're at, what type of material, building materials are present. Most retaining walls should last 100 years or more. So, they should be something that's solid. Untreated wood or Douglas fir walls last only about 10 to 20 years because they will decay due to the wood rot. Retaining wall is not supposed to move or crack. So if you see a retaining wall that's got movement to it, instead of being level, straight up and down, vertical, if it's leaning some way, one way or the other, it's probably beginning to fail. So something you definitely want to note to your client because that can cause foundation movement. It should have a drainage system, keep water from building up behind the wall and pushing it forward. So, there's a lot of things to look at on retaining wall. If you have uneven type lot sizes or yards where they slope down the side of a hill or a mountain or whatever, then these retaining walls become even more important in your inspection. Fields, most hillside home sites and many level home sites have varying amounts of fill soil used to fill low areas of the site, which creates a flat pad to which to build on. In other words, if there's a house is built on the side of a hill, they're going to have to do something to fill that soil, the pad up to make it level. They want the house to be level. So fields may have been used on only a few small dips or gullies, or the site was originally quite steep. A great amount of dill fill may be used. We've got one place here in Texas where the builder was building around a big lake just north of Houston, Lake Conroe. And this builder went out and began to dig canals were connected to the lake. And he'd dig these canals out and then use the dirt that he pulled out of the canals to put underneath the new home construction. Well, years go by, and what happened here, this dirt he pulled out of those canals, he changed the whole drainage as he dug the canals to put homes, calling them waterfront. Of course, the value went up big time. As he did that, though, and the home set for a little bit, the drainage of the pasture that he built in and turned into a home development, the drainage was natural. It began to occur natural again. And the homes that was built along the canals that this guy dug out, it began to wash the dirt out from underneath the houses. Of course, the slabs seemed to fail somewhat, and because the soil was not stable, it had dug it out and filled up underneath the house. So, you never know what builders does. Time the inspector will get out to a house and begin to look at it. We don't know the history, so all we can do is report what condition of the house is on the day of the inspection. So just be careful about that. If you see a slope in the backyard or a canal, whatever, pond, tank, whatever you want to call it, then there could be some issues on it. I'm sorry, I hit the wrong button there. It's difficult to determine by visual inspection alone whether the dirt underneath the house was existing or if it was filled during construction correctly. Improper fills may take their presence known by the damage that they occur. And a lot of times the damage that occurs, that's where you realize they had some type of wrong type of fill. To prevent distress from improper fill, a builder must install properly placed and sized piers to stabilize the structure. What that means is that the builder has to come in if the fill is unstable. If it's on a slope like that, usually they will put what we call drilled piers. They will put piers, could be different diameters of holes going into the ground that they drill into the ground beneath where the foundation is going to be, and they put some type of reinforced steel surrounded by concrete. They call them piers, and those piers will be scattered throughout underneath the house. That's what helps stabilize the structure. So unless you're doing a pre-pour type inspection, you won't see those. And if you're doing a pre-pour type inspection, you probably would see that and be able to tell, hey, this house has piers. Plus, you should have an engineer's drawing and a seal put on the plan to show you that, hey, this is how the slab was originally designed. This is what they're doing. That you can actually verify it for your client. So thanks again for attending our webinar. I hope you've enjoyed this one and that you'll attend the rest of our 6-part series. Again, this is Paul Roebuck. If you have questions or comments, you can send them to me, paul@internachi.org, and I'll try to respond to you as quick as we can, and we'll get going on answering to get to the next webinars. So again, thanks again for attending.